Okay, as promised, we are going to have an intro to the 555 timer. This is a new circuit that we're going to work on for the next probably 2 weeks, if not 3. Introduce you to the different aspects of the 555 timer. Now, you actually have already been introduced to this. You just didn't know it. In the project that you did, the soldering project that had all those flashy lights, you put in a 555 timer. It was the little black chip. It had a spidery looking thing with 4 legs on each side. That was the 555 timer. Now, what did that 555 timer do for us? It's that little IC chip that has an output. And this is the 555. One of those 8 pins is an output. That output, depending on what we do to the outside of that 555, creates for us a waveform. Now on your project, what that meant was when this was high, the light was on. When it was low, the light was off, and so on and so forth. So you can see using this waveform that it was flashing those lights, which is what it was supposed to do. Now, there's also a lot of discrete components out here attached to the other pins, and you guys noticed, some of you anyhow, when you messed those up, some of the resistors and so forth, when you had them in the wrong positions, this became skewed, or I should say your lights didn't flash properly. Well, your lights didn't flash properly because you didn't have it properly set to do that waveform. Now, we have to do a review here. We have to remember that that is our period. We have to remember that also we have a cycle. The cycle repeats. That is one cycle, this is another cycle, this is another cycle, and so on and so forth. And all we do is concentrate really on this one cycle because we can get all of our information from that. We have to remember that the period is 1 divided by the frequency, and that the frequency is 1 divided by the period. Frequency is measured in hertz, and the period is measured in seconds. Okay? Now, this is important here to remember because this is going to come into effect when we calculate our values for all of this stuff that's going to be out here, all those resistors and capacitors. We now have to use these equations plus some others in the specification that I'll talk about in just a minute, that will then give us our values for all those R's and C's to give us the waveform that we want. Now, there's 2 different waveforms that we're going to concentrate on, and I'll get into more of those in the spec, but I want to talk about them right now. One is called an A-stable. So it's an A-stable 555 timer, which means it's called free running. And as you can see, that's exactly what it does. It will have this waveform forever and ever and ever in a day until you cut it off, or you shut it off, or you remove power from your circuit. That's called an A-stable. Oops, A-stable. Now, I'm going to move that up a little bit. The other one we're going to have is called a monostable. The monostable stays low until you want it to go high for a period of time, and then will stay low again forever and ever and ever. Or it can stay high and then go low and then back high forever and ever and ever. Usually these little pulses here are used to turn things on and off. It's a really easy circuit. This one is actually simpler than the A-stable, but this one is called a monostable, mono meaning 1 pulse, and then that's it. That's all it does. There's a little trigger mechanism on the 555 that causes this, which we'll get to later. Okay, so we now will dive into the spec to figure out how to do a free running A-stable and a single monostable waveform using our 555 timer. I'm getting used to this whiteboard thing. Okay, there's your quick introduction. Now let's get to the spec.